Okay, Rachel, let's continue to focus for a moment on this special case that has B and C both set to 0. So you recall from the first clip that we had a few minutes ago, you could have plus bx plus c in this term, in this equation, but let's continue to focus on that special case now, okay, with b and c 0. So you only have the x squared, okay? When this is the equation, y equals ax squared, think about it. What this is telling you, look at this x squared term. What does it tell you? It means that for the same value of x, but the same absolute value of x, but if it's negative or positive, meaning the absolute value is the same, that is minus 3 or 3, okay? The absolute value of minus 3 and 3 are both equal to 3, okay? Absolute value of negative 3 and absolute value of 3 in both cases is equal to 3, okay? So, but when you square a number, the negative 3, you square it, it becomes 9. The plus 3, you square it, it's still 9. So it means that your y values, you're going to have, this is telling you that you have a situation where for negative 3, for x equals negative 3, and for x equals 3, you still will have a value of y equals 9, right? So x equals negative 3, x equals 3, you have a value of 9. So you go up, this is minus 3, 9. You go up, this is 3, 9. So that is why you have a parabola like this that is symmetrical. So this is your parabola. Ignore the one below the y-axis for the x-axis for now. Just focus on this U shape that is facing up, okay? This parabola facing up. You see, it means that for negative 3, for x equals negative 3 and x equals 3, the value of y is the same. And that's why you must have it, you must have a symmetrical shape, and also it passes through the origin, because when x is 0, y is 0, it passes through 0, 0. Okay? And it has to be this shape, facing up. Because whether you're on this side of the y-axis, negative x, or you are positive x, when you square both sides, you're going up. The y is going up. That's why this faces up. Okay? Now, consider the case where you now have this constant a. With this constant a is some negative number. Negative. It doesn't matter what number it is, but it's negative. Okay? So what will happen? Well, the rest of it will still want to behave the same way. You still square minus 3, you get 9. You square 3, you get 9. But because of this negative, it's going to now reflect everything downwards. So the reason that you will have a downward facing parabola is because the constant sitting next to your x squared is a negative number. Okay? It's not because of the x and y themselves, because whatever values x takes on, when you square it, it becomes a positive number. But if this number is negative, sitting here, remember that's not squared. This constant is not squared. So if it's a negative number, it keeps its negativity, and that makes all y's to become negative. So no matter where you are, it will now be just a reflection of the upward facing one. It will now reflect along, it's like you have a mirror along the x-axis, and it will reflect it back down this way. So this is the case where a is a negative number. Okay? Whereas the first one, this one facing up, is a, is a positive number. Okay, that's the only difference between upward facing and downward facing in this special case. Is whether this value a is negative or positive. That's the only difference. Because every other thing you do, because of the squaring, because you square x, every other thing will really want to be positive. But the negative will cause that to happen. And you understand why there is symmetry. It's because whatever you do on this side, the x values will be the same, even when the x is negative in terms of y, because we're squaring it. Okay, when you square a negative number, you get a positive number. And that's why both sides, negative x side, positive y side, positive x side, all will be plotted up above the x-axis in the positive y domain. Do you understand that? Okay, let's leave that alone. Now, look at this case. So, now let's focus on this part now. Okay, just this part we're going to focus on now. Look at what's going on. I have changed something. Instead of y equals ax squared, I have changed it to x equals ay squared. I know that this is unusual in your algebra so far. You are used to seeing putting y on the left hand side and putting the dependent variables on the right hand side. It really doesn't matter. I mean, you can rearrange. You know, if you really wanted to rearrange, you can do that and so on. But in the case of plotting these parabolas, it helps to do it this way. And actually, your book follows that, but it's even a more special, a different notation in your book, and we're going to do that on this side next. But let me do, because I've set this up this way, let me do the complement of it, which is this. Now, what's going on here? X equals ay squared. Look at this case now. What is it that you have here now that it doesn't matter whether it's negative or positive? Well, it's y. Because if y is negative 2, you get y squared is 4. If y is 2, you still get y squared is 4. So it means x will not change its value whether y is positive or negative, as long as it's the same absolute number we're dealing with. So negative 2, so y being negative 2 and y being positive 2, x will not be able to tell the difference.